Welcome back. So, let's talk about some of those historical airbursts and impacts, look at some of the damage and destruction that was done. So, in 1908, in Tunguska, Russia, kind of northern reaches of Russia, there was an airburst. So, a large, asteroid came into the atmosphere, but blew up. And the after effects are seen here for miles. Trees were just blown down. Thankfully, this happened out in the middle of nowhere, Russia, for the most part. So, humans were not affected as much as the natural environment, which is, it had to be pretty weird to get into this area and say, what happened to all the trees here? So, kind of, otherworldly. You start to think of, aliens. Well, no, it was an airburst. So, here's an image of recreation of the airburst and the shock wave that was created. You can see that the angle of this shock wave, again, as these shock waves, they're hitting at an angle, so it's kind of like a shovel, and picks up and throws anything that's in its way as it kind of radiates outwards. So it leveled trees for over 800 square miles. That's an area. The explosion generated winds approaching hurricane force winds over a very wide area. So the asteroid itself is about 120 meters in diameter. And in lab, we'll kind of figure out a way to figure out the size of these based on measurements and information. So the asteroid itself, 120 meters in diameter. So a big one. The height of the airburst was just over about 5 miles in the air. It was actually 1,000 times more powerful than the Hiroshima atomic bomb. Can you imagine that? So it flattened 80 million trees over, again, 800 square miles of forest. So that's about 28 miles in all directions. Just the trees just so almost 30 miles in all directions. Trees just swoosh, done. What else do we have to say? So it was the largest witnessed airburst to date. There were 3 reported deaths, but not confirmed it was from the airburst itself. So there was 3 deaths associated in the area there, but again, they can't really link it directly to this airburst. The shock wave from the airburst would have measured a 5.0 on the Richter magnitude scale, so a lot of energy released there. An explosion of this magnitude would be capable of destroying a large metropolitan area. So if this happened over New York, Los Angeles, Phoenix would be flattened, essentially. But the surrounding areas, probably just fine. But again, it's from the shock wave itself, the explosion. Kind of very similar thing happened also in Russia, in Chelyabinsk, Russia. There was another airburst. This is in 2013. Heavily documented. Cameras, dashboard cams, security camera footage, heavily documented. You can see kind of the after effects, kind of where it kind of burned up, came in. This is where the explosion occurred and how it just kind of petered out from there. So here's the meteor, the flash of light, the explosion, and then from there, most of it just burnt up in the atmosphere. Some small pieces hit around the area, but again, most of it kind of burnt up. So here's some cool videos to watch from Chelyabinsk, so make sure you're watching those. It does detail or show you some of those kind of camera footage from security cameras, dashboard cameras, etc. In this case, much smaller than the Tunguska event, so it was about 20 meters in diameter, but the height of the airburst was 25 miles. So not only was it smaller, but it was also higher in the atmosphere when it exploded. Therefore, less of an issue. So it was only 33 more times more powerful than the Hiroshima atomic bomb, but again, it exploded pretty high up in the atmosphere. So it did cause some destruction. If you watch that video, you'll see. But nothing like what the Tunguska event would have been if it happened in the same area. There were 1,500 injuries, indirectly, most from broken glass, broken windows from the shock wave, kind of hitting, rattling some things. 7,200 buildings in 6 cities across the region were damaged from the shock wave. Mostly windows, but some doors and stuff. It was the largest known natural object to have entered Earth's atmosphere since the 1908 Tunguska event. And we really didn't know about it. So anyway, those are airbursts. The next major event, probably another airburst. What about some impacts? Some smaller ones with documented proof of them. Just some fun ones to look at. So 1938 in Illinois, an impact went through I'm kind of blocking it, but through a garage, through the top of the car, through the seat, hitting the muffler. So you can see he's holding the material there. So there's historic. In Alabama, came through and hit this lady in the hip while she was, I think, sleeping or laying on the couch or something like that. So, these things do happen. In 1992, came through again a garage, hit the back corner of this car, and then they brought it to a car dealership just so you can come see it. So anyway, just some fun ones. 2003, again, through the roof of a house. Luckily, there was no one here at the time, so it just kind of went through the house. Obviously, caused a lot of damage to the roof, but no injuries. So most of these impacts, really no injuries. And then let's get to some of those bigger impacts. So this is the Barringer crater in Arizona. Some of you may have been here. It's known as Meteor Crater. More on that in a second. So this happened about 50,000 years ago. The crater itself is just under a mile wide and about 650 feet deep. An iron asteroid hit this, and it thought to have been about maybe 25 to 50 meters in diameter, about 80 to 160 feet. That's what, so, something, again, about 100 feet caused something about a mile wide. So, yeah. So it was actually the first impact crater identified on Earth back in 1903. A lot of these other craters that were found, they were thought to be volcanic in nature. Same with this one. It actually started off thinking that it was a volcanic crater because it's just outside of Flagstaff. And we know Flagstaff has a lot of extinct volcanoes. But it wasn't until 1903, this was the first place that someone was like, no, you know what? This is not a volcano at all. This is from an impact, from something from space. And then people started looking at all the other craters. I'm like, oh yeah, this one too, this one too, this one too. So it's kind of cool. This was the first one identified. It was also the training site for the Apollo astronauts for the moon mission to help them, work with craters, what they might be exposed to. The explosion was equivalent to the explosion of the 1908 Tunguska event. So you get this thing big enough, moving fast enough, at a particular angle, coming in, hitting the Earth. Again, material ejected out, some of it molten, cooling, turning to tektites. Others just kind of rock, just get, excavated out. But what you can see when these things hit, almost like if you jumped into a pool and did a cannonball, the material kind of gets flung up and out. So you can see it kind of gets flown up and kind of starts to bend over onto itself. So it's very interesting that we look at the geology along the rims of some impact craters, the Barringer crater specifically. We can see the layers of Earth kind of that were up and over. So they're kind of folded up and over. So the ground got folded up and over onto itself. So what that kind of looks like is we see these layers of rock, and they kind of repeat because you can see that they've been folded over. They've been folded over. So again, here's another shot. So we have the Coconina Sandstone, the Toroweap Formation, the Kaibab Limestone, the Moenkopi Formation, but you can see it kind of been folded up and over. So in Toroweap, Kaibab, Moenkopi, Kaibab, Toroweap. The reason that happened, folded up and over. So anyway, that's a Meteor Crater. Think about that name for a second. Meteor Crater. Where are meteors? Should that place be called Meteor Crater? I have an issue with that. But in any case, I digress. What about the Chesapeake Bay, Virginia? So this crater, so Barringer, 0.8 miles in diameter. This one, 56 miles. 56 miles. Pretty big. So this happened 35.5 million years ago. I misspoke a little bit. So on average, so the widest is 56, but on average it's about 53 miles in diameter and almost a mile deep. So there's kind of two parts to it, an inner and outer crater, because when something this big hits, it kind of almost like a cannonball, parts go up, come back down, go back up. So you can get this kind of like ripple effect. Again, it was an iron asteroid, thought to have been about 1.9 miles in diameter. So it's a pretty big one. So now, but in this area, I mean, it's so large, you don't really see an impact. So this is kind of getting towards back towards that that idea that, you know, the moon looks the way it does. There's no atmosphere, no water, no plate tectonics. But here on Earth, we got all that stuff. Sometimes it hides impact craters. And this is a great example. This is a great example. We didn't know this was here for the longest time. And it's the largest U.S. impact crater. We didn't really discover it until about from 83 to 93. There was some oil drilling going on in the area. So again, this was only about, what, 30 to 40 years ago that we actually found this crater. And it's millions of years old. So all this oil drilling was going on. So what they kept finding as they're drilling is that layers that contain those little glass tektites, as well as something called shocked quartz. That's the quartz mineral that has been changed, metamorphosed by, excuse me, heat and pressure. I believe more on that in the video, the assignment that we'll watch. I believe. I could be wrong, but in any case, so we get these tektites and these altered quartz minerals, really unmistakable signs of an impact. So they kept finding these in particular layers that they were drilling. So just a quick side note, when they were looking for oil, they drill down for a bunch of test holes, and they pick up and they pull up the sediment to see what's in there. Is it oil rich or is it not? But in any case, when they're doing that, one of the layers they found, they kept finding these tektites and this shocked quartz. So what they came to realize is that the surrounding region suffered massive devastation in the wake of this impact. There was mega tsunamis, and then started to see that in the geologic record as you're looking at the area around the Chesapeake Bay. Today, they're still feeling impacts from the impact, whereas land subsidence, groundwater flow, and earthquake issues are all in the area are attributed to this event. So we see, here's that inner crater and the outer crater. So the impact itself, massively large, right? 85 kilometers, about 53 miles on average. So we see faulted bedrock, faulted layers above it, and because of this impact, which all lead to earthquakes in the area 30-some million years later. Different layers will alter where groundwater will flow to, all due to this impact. What else did we say? Subsidence. So that land is sinking, subsiding, again, moving, all due to this broken up material due to this impact. It's just such a large area. And no one would have known this was here unless it was for all of that drilling down to the depths to look and analyze the layers of Earth and see this material. And so they kind of put it all together, and there it is. So let's pause here. When we come back, we'll talk about one more impact, the Chicxulub impact that occurred down in Mexico. It's a very famous impact, so it's a little bit longer in length. So we'll save that for the next video. I'll see you back here in just a second.